The last decision rule that we're going to talk about, and one of the most important, is called the internal rate of return. And this is the most important alternative, although it's somewhat not an alternative, it's more of a companion to the net present value rule. In other words, if the NPV rule is the golden rule, the internal rate of return is the silver rule. And it is often used in practice, and it's intuitively appealing because the internal rate of return is a percentage-based rule. So the NPV rule can often be misleading or sort of difficult to grasp if you're not intimately involved with the mechanics of the investment, because the NPV just gives you a pure number. So, for example, in the project we've been looking at, the net present value is $12,627. Is that a good net present value? Is that a bad net present value? Is that enough? We know that it's greater than zero, and the NPV rule says, hard and fast, any net present value greater than zero we should accept. But we don't have any indication of whether this is a really good return for us or not. Is $12,000 better than $1 million? Well, it might be if the investment required on the $12,000 NPV project is only $10,000 and the investment required to make $1 million NPV is $10 billion. Right? Then we have this vast difference in the requirement of investment, and we might have a different choice to make. The internal rate of return is something that can help us determine that. And it's based entirely on the estimated cash flows. So what the internal rate of return does is it solves the net present value, or it solves the net present value function for zero. Right? And you can see how that as we work the problem. Right? But more practically, what happens here is that we set the NPV function equal to zero and solve for the R that makes that true. Right? So you can see the net present value function written out here analytically. This is the NPV function for 3 cash flows minus the initial cost, and this is the common problem we've been working. If I plug in the numbers from the common problem, we see that the 3 cash flows are discounted at the 12% required return. That gives us a net present value of $12,627. What you should note here, though, is that the most sensitive variable in this formula is the discount rate. That's this variable R. What we have set is 12%, which is our required return for this project. But if we solve this function for any value of R, we'll get a different NPV. And what that means is that if we decide that the project has a different level of risk than the one that we think it is, that's caused us to choose 12% required return, we would get a different net present value. So if I thought the project was actually less risky than what I think now, let's say I think it's only risky enough to justify a 10% required return. Well, then if I plugged in a 10% required return, I'd get a higher net present value. And you might say, well, how does that play into our decision making? Because I would be able to fudge the numbers here a little bit, right? Let's say I'm the manager and I'm trying to get my project taken on. I want to present to the finance team the project with the highest net present value. And I can do that just by assuming a lower level of risk and a lower discount rate. Right? So R is an assumption here because the risk is an assumption. It's based on what the risk of the project is going to be. And if we're wrong, we could cause ourselves to take a project that's really going to be a bad job for the company. So what the IRR can do is help us determine how wrong we can be before we start to lose money. Right? And you can see how that plays out when we look at the net present value profile. The net present value profile is a graph of potential net present values against potential discount rates for the project. So if we flip back and we look at that analytical function, the net present value profile is a graph where we set the discount rate first equal to 1%, and then we see what the NPV is. And this is the NPV profile of our common project here. So you can see that at an NPV, that a discount rate of 1% gives us an NPV near $60,000. And then we set the net present value equal to increments of discount rates. And a calculator would do this, at a very small increment. We could do this here, I did it at 1%. And so you can see that at 2%, the NPV is 50%. At 6%, the NPV is like 35,000. At 10%, the NPV is like 25,000, or a little over 20,000, I guess. And at 12%, which is our required rate of return, that's what we think the risk is going to be. At 12%, we have an NPV of 12,627. What the IRR does is say, at what level of the discount rate is net present value going to be 0? And we can see that it solves here for 16.13%. That's about 0. If you plug it into your calculator, plug the common problem into your calculator, plug in the internal rate of return as 16.13, see that you get almost 0 for NPV. And what that gives us is a boundary for this project. We might be wrong about the discount rate. We might be wrong and have it set too high. We think the project is more risky than it actually is. Or we might be wrong in the other way, and we think the project is less risky than it actually is. And that's the one we have to be worried about. Because if I'm wrong in the other way, I could be taking a project that actually, in reality, has an NPV of 0, and I just made a bad assumption that caused me to think it was positive. Okay? And so the IRR here is comforting in this particular project because the internal rate of return is about 4% greater than the required return. In other words, we think the project's risk level justifies a 12% required return. The internal rate of return says if we're wrong by 4%, we would take a bad project. But 4% is a lot to be wrong. We might be wrong by only 2%, in which case a 14% NPV is still, a 14% discount rate still provides a positive NPV. Okay, so the IRR gives us a hard cutoff rate for what we should do and how we should think about whether a project is still acceptable even though we know our assumptions about risk are probably going to be wrong. So if we look at our evaluation criteria, we see that the IRR is successful in them. It does account for the time value of money because we're using the present values of the cash flows. It does account for the risk of the cash flows and in fact, it gives us a boundary for how risky the project is going to be at all different possible levels of risk. And it does give us an indication of value actually at every level of risk. So do we consider it for our primary decision criteria? And the answer is no, because there are two scenarios in which the internal rate of return rule fails. And because those two scenarios exist, we use the net present value rule as our primary rule. The internal rate of return rule, we just do it almost always, we do it together with the NPV. But if they have a disagreement, then we choose the net present value decision over the internal rate of return decision. That being said, the internal rate of return is really appealing. People like to see percentages, and we like to know this boundary. Your boss is really going to appreciate the internal rate of return because what you'll be able to say is, we have assessed this project, we've estimated the cash flows, we've estimated the potential risk, and we think the appropriate required rate of return based on that risk is 12%. However, if we're wrong, the internal rate of return is over 16%, so we could be wrong in a big way and still have a positive project here. And that's why this kind of rule is so appealing to people. So if we look at the summary of our decision rules, and again, this is arbitrary because I picked the payback periods and the accounting return hurdle, but you see that we accepted a project based on NPV and IRR, but we rejected based on the other three. And this is not necessarily uncommon. In other words, the payback period and the discounted payback period have a specific use, and that is to bias us towards projects that finish quicker because they pay back sooner, and that gives us liquidity. And the other two, the net present value and IRR rule are biased towards actually determining total value, and total value could be a long-term thing. But if we see that they are changing, if we see that there's disagreements among the rules, that should give us a little bit of pause, and it should cause us to go back and evaluate these rules more consistently and look at the project and try and determine why we're rejecting good projects with these other rules.